So welcome everyone to our ongoing series that we host on CADRE platform. Just to remind everyone who's new here, and CADRE is a big data infrastructure platform that we hosted in the cloud that is open for everyone. We host data set like Web of Science, Microsoft Academic Graph. Web of Science needs additional data agreement with a vendor, but Microsoft Graph is free for everyone. And we will be launching our beta version finally. Actually, it's already rolling out today. So if you keep checking our website, you will be switching up to our new beta version on a hour-to-hour basis, because it's a big system. We're rolling parts of the system every day. The biggest news is future user data will be persistent after the beta launch. Alpha data will be migrated. So if you miss your alpha data, please contact us. It will not be connected after this end of this week. We will, with the launch, come with an entirely new graph query engine with new versions of data as well, both for Web of Science and Microsoft Academic Graph. We'll also have a new feature for sharing public reproducible packages. We will be running a demo on next Monday, so please mark your calendar. We'll help you through the new features. We also enable a new trial option for some of the paid services. So if you need more information, get on our website, contact us, and subscribe to our newsletter. We have a lot of partners. Recently, University of Toronto is trying us out. We hope they will join us in the future. Some details of how you can try if you're new to CADRE and you want to tell your colleague in your institution to at least give it a try. We want to acknowledge the Institute, the Museum, the Library for supporting us. We also want to acknowledge our data providers, Web of Science and Microsoft, for supporting this webinar series. And we have a short poll, I believe. I want to launch. Where's the option? Stephanie, can you launch the poll?
There you go, I just did it.
All right, thank you. It just take a few minutes to, a few seconds actually. It's a short poll. This year we've been quite active. We launched our alpha version back in February. We started a new fellows program with the coronavirus related literature. Beta launch imminent, going on right now, and our fellow teams has been presenting in this webinar series throughout. Today is just another example. Just if you just remind you what happened last month. Our fellow team from University of Michigan presented their work. Today this team led by Adam Pelauge and Cody Borner. I should have inserted my own picture here because I've been in closer collaboration with this team personally. And but what Adam will be presenting today, he will be the sole presenter today, unfortunately. Is fresh off the oven. I'm just providing him new data like a couple of days ago, and I saw his tweet earlier today. Exciting new result right off the gate. So I'm just as curious as everyone here to see the new results. Coming up in November next month, Samuel from University of Michigan will present his own personal project. In December, our fellow team from Purdue. So lots of exciting content coming up. Stay tuned and keep in touch with us. A lot of resources on our website as well. And without further ado, I'll switch my screen to Adam. And I will be here. So if you, Adam will be the main presenter, but I'll help answer any data-related question myself.
Okay, thank you, Sharon.
While you're starting up, let me just briefly introduce Adam. Adam Plosy is an assistant professor at the Center of European, Regional and Local Studies in EuroRAG, University of Warsaw. He specializes in interdisciplinary studies of regional and local development, science of science, and the policy and policy evaluation. That's why today he will be presenting our work on how the global network of air transportation and scientific collaboration are related to each other. This is a continuation of our previous work. If you heard our previous work where we connected air transportation network with collaboration of Indiana University and 4 other institutions here in the US, this study is going to be way more detailed. We include global networks, and we're doing some of the latest data with precise geo coordinates. Adam, please share your screen.
Okay, thank you. Welcome, everyone. I hope you can hear me well. So let me share my screen. So I believe now you can see my first slide, no presenter view, just the slide. That's correct?
Yep, you got it.
Great. So our study is about global network of air links and scientific collaboration. And our main result is that we have a quite robust effect of the robust effect on the impact of long-haul flights on research collaboration. And let me start from a very short introduction why this topic is important and why we should study it in more detail. It is well-known fact that scientific collaboration is related to space. There is a lot of evidence that the likelihood of collaboration declines with growing distance between people, between institutions, between countries, and there is a lot of research that tackles this question on a micro level, on level of buildings, districts in a city, cities, or globally. There is also a lot of work done within the so-called gravity model when you include not only distance, but also research capacities of involved parties. But what is interesting, there is a very low number of research that takes into account real transport connections between cities, regions, or countries. So the main variable used is just the pure distance measured along the air, and we know that it does not easily translate into real accessibility, real connections between different places across the world. And on this slide, you have a number of studies that address directly this issue, and you can see that they are rather of limited scope. They are mainly done on a country level. So, for example, Swedish case study, the Netherlands case study, Chinese case study. What is mainly done in this research is analysis of road travel time or high rail speed high-speed rail, sorry, transport networks in Chinese cities. If we look for air transportation connections in the area of scientific collaboration, there is a very limited number of studies. One is our study with Shoran and Kati, published in this September, I guess. And there are other two. One is particularly interesting, the study by Catalini, Rosen, and Gallet. But this is again study limited to one country, in this case the US. And the other study is kind of also a country case study done for Sweden. So there is some potential to contribute new evidence on a global level, on the overall air transportation network in the global scale. And this is what we like to do in this project. And I would like to structure my first part of my presentation around 3 papers that are kind of a background for understanding what we are trying to do. One is our paper that I mentioned and Shoran mentioned. The other is paper by Fortunado and colleagues. And the third one is paper by Campant and Janak Bizawa-Drot. And this one is especially important for our present study because what we are doing, we are basically taking their approach and we are applying it to scientific collaboration. So we are using discontinuity that they discovered and instrumental variable that they constructed. They use it for another purposes, and we seen a potential to apply it to our topic. And I will explain it in more details in a few minutes. So our previous study was limited to 4 institutions: University of Michigan in Ann Arbor, Indiana University Bloomington, and Indiana University Purdue University campus in Indianapolis, and also Arizona State University. So you can see that it is very limited. But we are not looking into collaboration between only those 4 institutions. We actually collected data, like kind of a EGO network data for all those 4 institutions for all the collaboration across the world. So what we've done, we compared 2 separate networks. One is a co-authorship network, this kind of a EGO network style analysis, and this is depicted on the bottom of this map. And overall air flight network. So in a way, we had a like more or less complete network of air transportation and very limited sample of scientific collaboration. But we were able to produce some interesting results. One of the main results you can see now on the screen. So basically, what we can see is that the predicted number of co-authored papers is declining while the distance is growing. But more importantly, what matters is availability of direct flights or flights with less connected flights. So as you can see, if places are connected with direct flights, the expected number of co-authored papers is way larger, even in larger distances than for places that are connected with a very difficult tiring flight that connections that need more more steps on the way. So the key insight is already, I've kind of said that, and maybe if you are interested in the magnitude of this effect, so the main result is that one additional direct flight between two locations increases the expected number of co-publications by a factor of 1.4, so like a 40% more. So it seems that it is quite significant result. However, our study was a very serious limitation, not only because we had only those 4 institutions, but also our applied data were kind of uncertain. The source of this data is Open Flights database, is a kind of a crowd-sourced database, so there is no guarantee that the data are full, complete, and clean. And the other limitation was that that our data allowed only for a cross-sectional study design, so no time lags, no data to establish any causal links, I guess. So what I said in a moment is based rather on a kind of a correlational analysis, not a causal one. So inspired by a paper of Santo Fortunato and colleagues and their call for more experimental and quasi-experimental approaches applied to science of science, we were trying to find if we have a kind of a possibility to apply this to the relationship we are interested in. And we quite quickly and luckily found the paper by Kampante and Janagizavadrot, and we've seen the potential to apply it quite directly to our case. And so now I will introduce you to what they basically did and how their approach is working and how we can apply it to scientific collaboration. The starting point for Kampante and Janagizavadrot was the observation that there is a regulatory induced discontinuity at approximately, not approximately, directly at 12 hours of flights. This requirement is connected to things like number of crew required on board on flights, you know, the time that pilots and onboard crew needs to rest between flights, and how their like places to rest in aircraft should be designed, and so on and so on. And it quite directly translates into significantly higher costs of flights that cross 12 hours cutoff. And it turns out also that this 12 hours translates quite directly into the distance of 6,000 miles. So with this information, 6,000 miles, we can easily look at flights and distances between airports around the world, and to see what is happening at this very distance. And what they found is that indeed there is a interesting and significant discontinuity at this cutoff. The first panel A shows you the number of connected city pairs in like some in the bins in 2014. So you can see that up to 6,000 miles, there is a significantly higher number of connections, and just after this cutoff, the number of connections is far less. Yeah, and what is interesting, if we look at the data for 89, we can see that there was no such discontinuity. And why is that? It is just because in 1989, there was a very limited number of aircraft that were technically able to fly for a distance longer than 6,000 miles. And exactly in 1989, Boeing introduced a new aircraft, and a few years later, Airbus introduced new aircraft, and now they are kind of a popular, and technically it is quite easy to cross the distance of 6,000 miles. So we can see that we have not only discontinuity in 2014, but we had no discontinuity in 1989. So we can also play with this difference, and we can probably expect that at the beginning of our period there will be not discontinuity in co-authorship, and this discontinuity will grow up to 2014. And you can ask yourself why we will limit our study to 2014. The reason is basically starting from 2014, the air transportation regulations have changed, and this cutoff is up to 12 hours is not simply present. So we can probably observe if we can collect newer data that the discontinuity will be slightly diminishing. Of course, you can also ask yourself, probably the geography of airports around the world is strangely patterned, that discontinuity is not the result of this regulations, but simply by it is a result of locations by cities. And the answer is it is not the case, because if we look into potential connections between city pairs, it is shown on panel D, you will see no such difference around the 6,000 miles cutoff. So just to give you an intuition what Yanagisawa, Drott, and Campante did to establish their instrumental variable, they first of all looked into the distances of 6,000 miles, and this is the distance for San Francisco Airport. The thick red line is 6,000 mile distance, and those lines thinner are distances of 5.5 thousand miles and 6.5 thousand miles. So we have a range from 5,500 miles up to 6,500 miles. And what they did to construct instrumental variable, they simply counted number of possible connections in this broad range. Then they counted number of connections below 6,000 miles, and they calculated the ratio of these two sums. And it turned out that this very basic instrument predicts very, very well real connections for a given city. So I will come back to this instrument in a moment. It is not very intuitive, I guess, for the first time. So key insight from Jana-Gizawa-Drot and Campante study is that they were looking at the effect of air links on the local development measured by satellite night flights, and they found a very positive and robust result. And they found also that at the level of city links or airport links, air links induce international country co-owners, international company co-ownership. And most importantly, from our point of view, they constructed this nice and quite easy to play with instrument that can be applied for other outcome variables as well. So our present study. We for this presentation we used only data from Microsoft Academic Graph, and the reason we used this data was very simple. It is because Microsoft Academic Graph data provides right now geolocation of very nice percentage of institutions that they cover. So we can we were able to quickly implement our strategy without the pain of geocoding institutions. However, what we are planning to do is that we will geocode Web of Science data, not only because of the need of robustness checks, but also we believe that Web of Science data probably we will have more granular geolocations than geolocations provided by Microsoft Academic Graph. However, Microsoft Academic Graph geolocations are pretty well done. The second source of data is data from International Civil Aviation Organization, and these are proprietary data that we had to bought from this institution. And we also added additional covariates in mostly same or very similar to those used in the original study by Campante and Jana-Gizawa-Drot. And these control variables are related mainly to geographical information, as country, for example, distance from equator, time zone, other measures of distances, but also some socioeconomic measures as GDP per capita. And so what we have in our data set, we have first of all just raw numbers of publications as identified in Microsoft Academic Graph, and here you have a map for 1989, and here is a map for 2014. Quite reasonable picture, I guess, for those that are seen. I suppose all of you have seen a lot of scientometrics data visualized as maps, so the picture is pretty similar to other sources. So this is good for our study. So we can expect that results based on Web of Science will rather confirm our analysis than we linked publications geocoded on the level of institutions to all, actually not selected, major international airports. The definition of major international airport is provided by ICAO, and also it is the same exact definition that were used by Kampant and Yanagisawa. So you can see that those airports are mainly concentrated in Europe. In the US, there is less such airports, but broadly speaking, they are spread across the whole world. And what we've done exactly, we looked into two outcome variables, and we used two different methods to analyze relationship between air flights and those variables. First variable is very raw measure of international collaboration. It is basically publications with at least one foreign affiliation divided by the total number of publications at given location, connected to a nearest airport. I have to add that. And the second variable is the number of co-authored publications measured again at the number of airports at the level of airport pairs. And for the first variable, we used instrumental variable, and for the other, we used regression discontinuity design. And in the remainder of my presentation, I will show the results for both of these methods. But let me show you some more nice pictures. This is a map of internationally co-authored publications in 2014. Sorry, this is not 2014, it is 1989, and the title of the slide is not is wrong. So this is 2014. As one can expect, the number of internationally co-authored publications is growing. However, from this overall world view, it is quite difficult to see differences. So I prepared also some more detailed maps, and this is for, again, 1989, sorry for the wrong title, and this is the most important, I guess, slide for this presentation. This is these are internationally co-authored publications, actually share of them in 2014. So you can see basically that those kind of publications is concentrated in Europe. Basically, we have a lot of countries, small ones, and actually between some of them there are very weak borders. And on the other hand, there is China, where the number of overall scientific production is growing, as we know, but the internationalization is not that great. And coming to the second variable of interest, the number of co-authored publications measured by at the airport pair level, again, some in beams. This is for 1989. So for 1989, maybe there is some discontinuity, but really, if there is weak and rather suspicious. Nothing interesting is going on here. Kind of we expected. And in 2014, we can see quite nice discontinuity with a very different slopes, because here we have a even increasing number of co-publications as we approach 6,000 miles cutoff. And when we cross this cutoff, the slope is completely different. So basically, in the regression discontinuity design, the second method I will show you results in a moment, what we are trying to fit two separate lines on the two sides of the cutoff and to measure the difference around the cutoff, just to see what is the effect of this regulatory discontinuity in air transportation for long range flights. Grid city level. So for grid city level, and I am quite sorry about that, we use this quite not intuitive at the first moment instrumental variable. But I believe that in a while, when you think about it, it is quite not that difficult to understand. So basically, we are using this this ratio of the number of airports or airports that can be connected from airport I, and that lies in the distance of 5,000 miles, 5.5 thousand miles up to 6,000 miles, and we divide it by the sum of airports that are located in the distance in the range of 5.5 to 6.5 miles away. And to make it a bit more complicated, we are looking into quite kind of a weighted version of it, because as Kampant and Yanagisawa wrote, established in their article, this weighted version is even better in predicting real connections. You have seen that already, so I will switch to the to this slide. This slide shows our instrument at the airports around the world, and the main message from this slide is that our instrument is not the levels of our instrument are not concentrated geographically. So we can find airports, for example, here in the US, that have a high level of this variable, and that are very closely located to the airports that have a low level of this variable. So this is a kind of evidence that that this instrumental variable can be meaningful for further analysis. And finally, some regression results. So this is kind of a instrumental variable regression results, reduced form, if you know the technical stuff that is in the background of these calculations. And what we can see is that, yes, indeed, we have a positive results from this instrument. This is indicated by the first line. And what is also very interesting from the point of view of design itself and our expected results is that in 2014, the effect is larger and more statistically significant than in 1989. And probably, as you remember, we expect that the discontinuity is present in 2014, and not present or ambiguous in 1989. So this is kind of an expected result. And further, we added some control variables mainly international co-publications in 1989 to the years 2014 to 2017, just to control for background connections, scientific connections. And what we can see is that the magnitude of the effect is a bit lower, but the effect is still statistically significant, even if we control for a baseline scientific collaboration that existed in the earlier years. Then we can look also at the kind of spatial patterns of this effect, and maybe I will show you this slide. It will be easier to understand. So what we are looking here, we are looking how far from the focal airport the effect on scientific collaboration is present. And the models are organized by a distance from a grid cell point where the universities and other research institutions are located to the nearest airport. So we can see that the very close locations around the airports, up to 50 miles, we can see very strong results and very strong effects. In the range from 50 miles to 100 miles, the effect is still present, and it is still present in the other 50 miles range, but it quickly diminishes as we cross 150 miles, maybe not the threshold, but distance. So this is also kind of a expected result. And the last part of my presentation today is airport PERT level. Probably this is easier to understand than the instrumental variable regression, because this is the one that can be very easily depicted on the picture. So what we are trying to do here, we are trying to, as I said before, to fit separate lines on the two sides of the cutoff point of 6,000 miles. And what are the results? Again, the results are as expected. Here you can see minus signs, and this indicates that at the cutoff, the expected number of co-publication is decreasing by 6, by 8, by 7, and those three different models are dependent on the bandwidth. So bandwidth is the distance from the cutoff to the left or to the right. So basically we are looking for the place very close to the cutoff or further away. Optimal bandwidth is kind of not arbitrarily selected as 5,000 miles or 1,000 miles, but it is calculated based on distributions of the data at hand. And again, if we add some additional covariates, especially if we add scientific capacities at both ends of our relationship, the effect is declining, but it is still statistically significant. So the decline of the effect is quite important, I would say, from 6 or 8 to 2 or 3, but it is still statistically significant. This one I can skip. And what is more interesting is that if we compare regressions for 2014 and regressions for 1989, for 2014, as you have seen already, we have this nice, consistent, statistically significant results. And for 1899, we have very small magnitude of the effect, however statistically significant. But if we add controls for scientific capacity at both ends of our relationships, the significance is diminishing. So this is kind of an expected result, because as I said like 3 times in this presentation, we expect that in 1989 the discontinuity is not present or very weakly present, because the technical capacities for long range flights were very weak back then. So the conclusion is quite obvious for now, I guess. Long-range air links increase scientific collaboration, and we have some quasi-experimental evidence that can prove that. What is also interesting, that our study directly addresses the very specific type of collaboration. It is long-range collaboration. It is basically collaboration between continents, so very distant collaboration, and we can show that transportation is important for this kind of collaboration. What we are planning to do further? Of course, we have a lot of work to be done for robustness checks and make some results, especially in instrumental variable results, more easier to interpret. But we are planning also to add some other outcome variables, as co-affiliations, and we expect probably the effect will be stronger, because co-affiliations probably are more related to real travel of people. And we also will be looking into citation links. We've done already some analysis, and this is consistent with our results. As I said previously, we will be also working with Web of Science data, and lately I started to think that probably cooperating data will be also very nice in this framework, just to make our analysis like more full in a way, because co-patenting is a bit different than scientific co-authorship. However, it is in the same, or it can be in the same domain. So this is almost all I would like to say. I would like to add one more thing, that it is not on my slide, but I think that with our present pandemic situation, it will be very interesting to see what will happen next, because now international travel is in standstill, and probably this will be the real changing time where the internet communication will start to really substitute for international travel, which is bad for the environment. So I'm far away from taking from this from our study the conclusion that we need more direct flights between all the universities around the world, because it will induce more scientific collaboration and scientific productivity. Yeah. So basically, I'm done, and I'm waiting for your questions and probably suggestions. Maybe the last thing that I'd like to say you is that this is the very first time I presented these results. So and the topic is sometimes not that easy to communicate. So I'm still thinking about the order of slides, and what should be explained in a detail, and what can be just very roughly mentioned. So this kind of suggestions is also very welcome. Okay, thank you very much, and I'm stopping sharing my screen right now.
Thank you so much, Adam, for the wonderful presentation. And glad to see my hard work data is putting to great use. And we have time for a lot of questions. I saw Yulia already raised her hand, so please go ahead.
Hello, my name is Yulia, and I'm from University of Michigan. So I have a question. One is how did you select University of Michigan, for your analysis? And also, I was wondering, how did you approach author disambiguation? So how did you go about that? Thank you.
Mm-hmm. So the first question about University of Michigan is question about our old article, those limited study. For this the study that the almost whole talk was about, we used every institution around the world. So on 4 institutions, it was for the study that is already published, and actually we selected this kind of by expert decision. We had data on Indiana University Bloomington, and we wanted to add some additional institutions. And so we used criteria, as far as I remember, we wanted to have institutions that are comparable in size and that are, research universities, and that they are located in the vicinity of one major airport, because, for example, for Columbia University, you have this mess because you have many airports around New York, and it is additional trouble to connect institution and airports. And for the second question, outer disambiguation, is that this is not relevant for our study because we are playing with affiliations. So we are actually summing up publications at institution level. So we do not care about individual authors. So maybe.
But affiliations may also be different. Even for our university, it can be like University of Michigan Ann Arbor, just University of Michigan, or department this, department that. So
yes.
Okay, so I understand. So yeah, so we relied on the disambiguation made by the Microsoft Academic Graph team, and so basically they provide for their cleaned institutions, they provide geolocation. So we basically took that. And for Web of Science data, we will have to deal with this issue, and it will be hard work, I know.
Yeah, I can tell you, we did spend a lot of time disambiguating institution names for our university case study. And as you pointed out, we have to come up our own algorithm essentially. But compared to also disambiguation, it's much easier because you have fewer entities and smaller data set.
thank you.
Any other questions?
Yeah, I have a question. I just turned my camera off because my dog is very needy at the moment and is directly in my face. So I apologize for that. This is Jackie Wilkinson. I'm at IU Bloomington. I'm the project director for CADRE. And I find this really fascinating, couched in to conversations about higher education, the history of higher education culture. I think about how higher education institutions in the US and England have developed, where there's a culture of having these, bucolic small town colleges that are nested in the middle of nowhere, and how research like this really dings institutions like that, especially when you keep in mind the economics right now of American higher education, which most experts predict will have to seriously downsize, and a lot of small institutions probably those in small towns far away from airports and from city centers will probably be the first to go, unfortunately. But I'm very interested, in light of that environment, conversations about how COVID is going to push collaboration, because we have these incredibly sophisticated collaborative tools that allow certain types of disciplines to move a lot of collaboration online, but certainly some disciplines that are very physically located, or that where lab science is crucial, or where something can't be shared in the cloud, they wouldn't be able to be brought along with maybe some of those changes that COVID might accelerate, of completely remote collaboration. So I guess my very rambling question is twofold. If you're interested in breaking down kind of disciplinary boundaries of collaboration, and if you're planning on looking at this time period of COVID, like starting from January until, when there's a vaccine or a second round of a vaccine, and if you're planning on kind of comparing those before times to this current period, and what disciplines are impacted.
So yes, we would like to include disciplines to our study, and of course we can expect that there will be some differences, and it will be nice to see differences between disciplines that are more impacted by physical travel, and those that are not that much impacted. For the second question, yeah, it will be very interesting to do that, but I'm afraid that first of all we have to wait to have the data, and I hope we'll be done quite soon with this paper. Maybe not that soon, but earlier than the data where we can see COVID effect. And the second issue is that, as I mentioned, in 2014, air transportation regulations have changed. For some countries, they moved those. Broadly speaking, the regulations are now much lower. They are softened than they were before. So, and they differ between countries. For the US, it is a bit different. For the European Union, it is different. For China, it is different, starting from 2014. So, probably, unfortunately, the discontinuity of 6,000 miles will be losing its importance. Okay, so we will not be able, most likely, to use this instrument for the years of 2020, 2021, unfortunately. But maybe we can do we can approach this issue in with another tools. I hope so.
Thanks.
And I have one more thing to add, because you mentioned those internet communication and wonderful tools that we have, and apparently we had them in 2014 already, isn't it? And in 2014 we have a very like a highly statistically significant effect of a real, transportation between cities that are far apart. And not only the results are like for this study, but also the initial background study by Yanagisawa, Drott, and Campante. So this is really fascinating, that even with all this internet, the physical movement of people across continents is still important, or add something.
That is true. I do agree with that. I mean, a lot of the tools that we've had for many years. But I will say, I mean, we all know higher ed culture is incredibly stodgy and resistant to change. So I guess a bit of my hypothesis is that the pandemic is going to accelerate the use of some of these collaborative tools that might have been, you know, less fine-tuned and less utilized and less known to within academia and well used in academia, you know, around 2014.
Thank
Great.
you. We have time for one more question. Well, I have one question, Adam. Because you mentioned the new data you get from the Aviation Association, the proprietary data is very rich. Do you have any plan to use the actual like flight data?
Actually, actual flight data are already included in the analysis as a control variables.
Oh, I see.
Yeah. So, but what can be done with this data? We can, for example, use a panel approach because we have exact flight numbers and passengers for each city pair from 1989 up to last year. So we can do kind of a traditional panel analysis, and yeah, so this can be fun as well. But this will be something different than the work inspired by this article of Yanagisawa and
yeah, because my idea is that I think from what you showed today, you're basically replacing what they using economic data with scientific data, and I'm sort of wondering if there's a causal link from, say, flight to economic than to academic, sort of more complete picture. But that might be too complicated to model.
Frankly speaking, at first I thought that it will be very easy research. So we take their approach, they model, put our outcome variables, and it will work. It was not true because you have to really think about different control variables. So I played a bit around that, but I had no time to explain in details what I exactly did. And for example, economic growth variable are already included as a control variable. So GDP per capita is already there. But you are right. With this data, we can try to see, you know, to look into this triple relationship between science, transportation, and economic growth. Yeah, this would be possible.
All right. Any other questions? Thank you, everyone, for joining us today. I think we are 5 minutes past our deadline, and
Thanks, Adam.
Thank you very much. It was a pleasure.